got your practical book, right? Okay. So those who didn't bring, maybe you can try to go through the mark scheme. This is the first time you set the exam style paper. Okay. So this how what you set this week is how your practical will be. You have two experiments. Okay. The first experiment going to be completely plotting graph. That's what we trained you did before. Okay. Get 6 sets of data, plot graph, y equals to mx plus c, and you analyze after that. Second experiment, something new, totally new. You need to take how many sets of data? Only 2. And towards the end, they're asking for what is the 4 problem you face, what is the 4 problem, how to overcome. Second experiment, normally very, problematic experiment. Okay. While you are doing, you might think in your mind that, oh, why the apparatus like that? It should be like this. It should be improved here. It's a kind of that kind of the questioning and the creativity must develop in your mind. So that's the idea of the second experiment. And the Cambridge want to check how the candidate can come out with the problem of that experiment and how the idea to overcome. Okay. Like a Rutherford experiment, no? Rutherford experiment. We haven't done that topic. Next topic is nuclear Rutherford experiment. What he discovered about the atomic structure, right? The nucleus at the center and surrounded by electron. He did experiment with what? Alpha particle scattering, right? His student done that experiment. So while they are doing the experiment, everyone thought it's going to be in front. Oh no, but finally they found something like deflected at the back. Only the student get to know there is something deflect at the back. Okay, it's a very big discovery. The idea of nucleus is discovered. Okay, so the idea when they're doing the experiment, then only they will come out with some problems. So then how to overcome, how to conclude. You have to build that idea. Okay, so yesterday you did 2 experiments, both are mechanical. First is the spring, you balance it, right? So you get 6 sets of data, you see how the marks are allocated. You can mark, okay? The point where you not there, you minus 1 mark. Okay, don't mark the one you got. The one you lost mark, you just minus it 1. Okay. Okay, the first one you see. Okay, the marks in the mark scheme hand, they see your script, what they are looking for. Okay. First they are looking for is your value for y. Should be 2 to 8 range. Y is your vertical height, is it? With the extension, right? Extension is value for y with the range B1, B2 mark. B2 is the first reading, right? Yeah, B2 is the first reading. Yeah. Okay, should be Y2 mark. Let me download this first. Okay. Sorry. Okay. So next, anyone get less than 2, then you lose with the first mark. Okay. Next, the raw value of theta to the nearest degree. Value of theta is range of 40 to 50. And the theta must be no decimal place. Okay. You write 40.0 wrong. How accurate you are? Wrong. Because you don't know how to read the instrument. Instrument is a protractor, which R smaller scale is 1 degree. So R for the smaller scale is 0.5. When you measure the angle is 2 place uncertain, the whole story like I told you last time. You get 1 degrees. So 40 degrees, 1 mark. Okay, now next is about 10 marks for the table. Okay, you got 6 sets of successful reading. Okay, let me. Okay, so you get 6 sets of successful reading, you get 5 marks. Okay, you get 6 sets. 6 sets, you get 5 marks. Whether it's correct or wrong doesn't matter. You have 6 sets, you get 5 marks. 5 sets cost 4 marks. Okay, I think everyone goes for 6 sets, 5 marks. If you have help of supervisor to find to do the setting that day, even the procedure you don't understand, you ask the supervisor, you lose 1 mark. Okay, the procedure, you must read the procedure, you must know how to connect. If you got problem with the connection, you ask him to connect, then you lose 1 mark. Okay, but if there is an apparatus faulty, that day like a circuit, apparatus faulty, it's not your mistake. What you connect voltmeter, ammeter in a correct position, no reading, it's not your fault. So you come and see found that apparatus faulty, then they should given an extra mark, no minusing mark. Okay. Okay, so that's your 5 marks. 6 sets of reading. Okay, range 150 gram to mass should be more than 150 gram and should be less than 150 gram. Range of values include M is less than 150 gram and M is more than 400 gram. That means can have in between, but you must have at least one value less than 150. Must have at least one value more than 400. Then okay. Okay. The lowest you never go lower than 150, I lose mark. The highest you never go more than 400, I lose mark. How many mass provided that day? How many 100 grams slotted? 800. 6, never 6. 7, huh? 7. So you try to cover the range. Okay, go to the lowest, go to the highest. Don't pick the nice number which only covers the top. Try to cover as much big as possible. So range mark, 1 mark. Okay, the range cover at least 80% of the range. Okay. Okay, so that's 1 mark. Okay, next, your column heading must contain quantity, unit, must contain quantity and unit. Where appropriate, unit conform to accept scientific convention. M sin theta should be M sin theta. Theta should be in degrees. Theta should be in degrees. Okay, or theta / degrees. So like M sin theta in bracket like degrees. The theta is in degrees. Okay. The M, oh sorry, should be gram, but not degrees. So M sin theta is gram. What they are trying to say is like M sin theta in bracket degrees like /G. Okay, that's the answer. Okay, so that's column heading 1 mark. Column heading given 1 mark. Okay, how's your column should be? I go back to the. How's your column should be? The day. Okay, first is what? Sorry, alignment. Okay, first is what? First is your manipulated. What do you manipulate? Mass. So mass / gram or kg, up to you. The next is what? Y. So Y you need to repeat because manipulated. Y in centimeter. 1, 2 average. Then theta. Theta also you repeat. To average, then calculated, right? What? Okay, in degrees /G. Okay, so I hope your table like that. B and C is what?
It shows the inner input of values from the end.
Oh, you have to repeat it.
Or to repeat it.
Yeah. Okay, so let's you see the marks here. The marks. So 6 sets, 5 marks. 5 marks. Vertical heading. Heading should be 1 mark. Quantity over unit. Must be quantity / unit. Okay, so far this is the one. Okay, let's go back. What else? Column heading. Range. Yeah, range is 1 mark. So range, range 1 mark. 150, lower than 150 and more than 400. Mark. What else? Then this one. Consistency. All value of y must be given to the nearest mm only. Yeah. Value of y you calculate with what? What instrument do you use? Use ruler, right? Ruler, right? What do you use? Ruler, right? So ruler should be how many dp you need to write? If it's in centimeter, 1 dp. So anything more than 1 dp in that column, even average also 1 dp. So you get mark. If the dp is not consistent, one is 1 dp, another one is 2 dp, you lose mark. Okay. So this one mark. Okay. Next, theta should be what? Theta got mark. They giving for what? Consists of y given to the nearest mm only. Every value of m sin theta must be 2 or 3 SF. Okay. Final answer is this is should be 2 or 3 SF. Mixture can for the last one. One is 3 SF. The second value is 2 SF. Allow. Mixture can. But the rule is follows, right? M sin theta, how many significant to be used? Depend to the source. What is the source you have to follow? The m and theta. Check m and theta. What is the smallest significant? Use that significant for m sin theta. If you don't know how many significant to be used, go ahead with 3. Most probably 95% will be okay. Three significant to use. If you don't know how many significant to be used. Even to your theory, your paper 2, all the answers go for 3 SF, you won't get wrong. But the actual rule is the less significant. Most of the answers in the mark scheme looks like 2 SF in the paper 2. Because the data they give is list is 2 SF. 1 extra is allowed. Okay, so altogether how many mark? So 5, 1, 4, 7, 8, and this is 1, 9, 5, 9 marks. Then finally, value of m sin theta calculated correctly. Oh, you calculated correctly. Calculation for m sin theta is correct, 1 mark. So that 10 mark. Okay. Okay. Calculated correctly, 1 mark. So the table carries most of the mark, 10 marks. Be careful with your table. So I hope when you take data, these are the things, elements is there. Okay. I think all of you got maybe 5 marks for the 6 sets. Okay. Range is the one most of the time students lose mark. They never get the range. Repetition, in this case, they never give mark for the repetition. Sometimes they will have repetition mark. You better repeat or you are manipulated. Okay. Next, graph. Graph, many times I told you, 4 marks. Okay. These are the 4 marks given. First mark for axis. Okay. First mark go for axis. Okay, first mark is for the axis. So sensible scale, no multiple of 3. I told you this. Scale must be chosen so that the plotted points occupy at least half of the graph. Okay, the point must be spread half of the boxes given vertically and horizontally. Vertical got 12 box, the point must spread at least 6. Horizontally got 8 box, the point must spread at least 4. Okay, then you get the scale mark, axis mark. Okay, scale must be labeled with the quantity that is being plotted. Scale marking should be no more than 3 large square part. Okay, that means what? The scale at the side, 3 large box, you give a scale reading. If you go for like 4 boxes, you give the reading wrong. 4 boxes empty, you never tell what is the value. I don't think so many of you go for like 4. At least 2 boxes you give scale, so you get mark. It's all scale mark, a lot of criteria to be followed. One missing, you lose mark. Next, plotting of points. All observation must be plotted correctly. No blobs, no like you put a dot, like a dot for all the coordinate not accepted. Diameter of the plot points must be half a small square. Diameter of the plotted points must be half of the small square. Plotted points must be accurate to half of a small square. Okay, best is use a cross. Okay, cross is better. The smallest cross, one box. Okay, so this also normally student, these 2 points they almost look at. The third one, quality. All points are table must be plotted, agreed with this mark to be awarded. All point must be within 0.25 y direction of the straight line. Okay. Quality not only depend on you, depend to your entire class and the supervisor report. If the supervisor got a quality very close reading and you got scattered, you lose mark. Okay. You are close, you are perfect, not scattered, but supervisor is scattered, and other friends also scattered, so you lose mark. Understand? You are lying. Okay. You understand? Majority, because maybe the apparatus for that lab is faulty. So everyone getting faulty, scattered one, and the supervisor who is right is scattered and so on. So they go follow for majority. Okay. Let's see, all of you got perfect. Supervisor got scattered, so they follow majority. Okay, not supervisor who is correct also. Okay. So quality depend to the majority. Okay. Next, line of best fit. Okay, line of best fit 1 mark. Okay, line of best fit, as I said, whatever line you draw, make sure if 1 point down, 2 point up, accept. Okay. If 1 point down, 3 point up, wrong. Nothing up, only 1 down, accepted. You know that. If 1 point can be like anomalous. Anomalous. So far, any question from here? These are the 4 points for the graph. Okay, next is the gradient and y-intercept. How do you get gradient mark? The triangle. Okay. Make sure the triangle is. Cannot write. Okay. The gradient, the hypotenuse triangle must be greater than half of the length of the drawn line. Okay. Draw the triangle in your graph. You draw the graph. Draw the triangle. Okay. Which triangle? Which 2 points you take to find the coordinate? Okay. Make sure this coordinate is at least half of the entire line. Okay. The method of calculating must be correct. Both read off must be accurate. Half of the small square to be read both x and y directions. Let's see your small square. Your reading is one is 20.0, another one is 20.1. So the data you can read is up to half of the smaller scale. Okay, that means you can read, let's say it fall at 20 here, you can write 20.10. Should write 20.10, half of the smaller scale. Okay, half of the smaller scale means the range is how much? 20.0, 20.1 is 0.1, right? So half of the smaller scale, how much? 0.05. So you can write all the data with 2 decimal places. You can read half of the small scale. You find the grade. Okay. Okay. So then y-intercept? Y-intercept, use a substitution method. Always use substitution method. Take a fresh coordinate one. Okay, here last time I see 30% of the class was found to be y equals to mx plus c. They not even use the graph gradient. They go and take one coordinate, they substitute y and x. They get the gradient of the graph. They find the c. Oh no, what they did? They never even calculate the gradient. They draw the graph. The y and x, they substitute 2 coordinates from the table, simultaneous equation, find the gradient on y-intercept. It's totally wrong, right? What is the purpose then drawing the graph? The graph is to make use of the gradient. Okay, so that's a major mistake. Okay. Okay, so the last part is your
The triangle diagram begins find an orthogonal or
connects it. Now the points are not valid anymore. You already get the graph. Now everything is about the line. So you forget about the points. Okay? Like this.
So if for example, my line is like accurate to scale, and there is no in between, so my answer still be 2 decimal.
Yeah, half of this.
So my final answer.
Final answer go for significant. Okay. But reading from the data is like a decimal place because you're reading it. Okay, next. Okay, don't forget to say this. Okay. Value of P is your gradient. P equals to gradient. Q equals to y-intercept. Correct? Y equals to mx plus c. Y equals to mx plus c, your linear law. Compare, I think your gradient, you get P. So P unit should be any one of them. So this tells what? Your convenient, your choice. France, you use ruler to measure, you get centimeter. You want to put meter in the table, you are doing conversion, more work. But final answer, meter is good lah. Okay. So, but you can put any unit, right? You can put centimeter per kg, centimeter gram. So my advice is, if the instrument gives you centimeter, you go ahead, put it in centimeter. Okay. But sometimes the front page itself, the first data they ask you to collect before you go for the table, 6 sets, they ask you to take one data, right? The one data at the side, if they put unit, meter, then you follow meter. If they never put any unit for the first data, after you fix, they say get y and theta value, right? The first data. At the side, do they put any unit for your case? The first data, the y and theta, they never put any unit. So any unit will do. Okay. If they put meter, follow them. Then you do the conversion. Okay. So the P is this unit. Consider the value. Q should be this unit. Consider the value. This experiment, they don't care what value of P, Q you get. One get 5, another one get 5,000. As long as unit correct, you get marks. Only for this experiment. Some experiment they give range. Okay. Some experiment they don't. They go for unit. So don't think you should not do accurately. I don't know your case in your coming sitting, you might give range. So you better do it accurately. Okay. So that's the first experiment. Is it identical same? Okay, second experiment. Okay, second experiment, as I said, problematic one, only 2 sets of data, not demanding taking the reading. All raw data you take must repeat. Okay, must repeat. Draw a table, or you don't have time to draw a table. Just put a 2 line, just put M1, 1, 2 average. You do a nice table, good. If you don't have time travel, you do roughly. Also given mark. Okay, you see the mark scheme they put. First, all values either nearest to 0.01 or 0.001 mm in the unit in the range of 0.25, 0.45 mm. A2 is what? Diameter. A2 is the diameter? Okay, diameter you use what? Micrometer, right? Micrometer, right? So 0.01. 0.001, you do have micrometer with 3, but the one given to you is 50 intervals, right? So 0.01. Our case is all 0.01. Okay. 0.01 mm. Okay. You got 5 millimeter, you must write 5.00. Okay.
So what if I automatically convert it to meters?
Okay.
Because like the next question is here.
The side did they put mm, the unit?
No, it's just blank.
Blank. Blank, any unit will do. But as I said, conversion sometimes can be error, right? And time consuming. So choice is yours. If I were you, I won't convert. As long as they put a unit, then I convert. Okay, correct calculation of A with a constant unit and power of 10. Okay, A, they just said correct calculation. That means use the correct formula. The final answer is correct, you get mark. Correct unit. You put millimeter, then area is what? A is area, right? Millimeter square, the unit 1 mark. Okay. Correct calculation A and consistent unit and power of 10. If you put millimeter square, you can put it in a scientific standard notation if you want. If you don't want to put, good. But it's a good practice to write in standard form, right? You got 0.005. You write 5.5 times 10 to the power of -3 standard form. That's a good practice for science. Okay? Big number we can squeeze into little digits. Okay, so yeah. Next, value of L appropriate to the range of 10 to 20. Okay, L length from 10 to 20. They ask you to measure 15. The reading must be, they give a big range, 10 to 20. And 1 decimal place because ruler. Okay, next is something new. This one. Find the percentage uncertainty for L. How do you find percentage uncertainty for L? Change of L over L times 100%. L, you know your value. Change the value, go for what? 0.1, right? From your ruler. But you see here, they give 2 mm to 8 mm. So you put 0.1 wrong. Okay, weird for this case. Normally ruler is 0.1. Practical, they think that sometimes you measure, you might have a parallax error, maybe the spring is winding or kind, they add the error. So we don't know how much to add. Okay, theory part, ruler 0.1 correct. Half of the smaller scale that works. When you come to this second experiment, you have another method. Okay, we follow the next method. This method not consistent. So I think we don't follow that half of the small scale to find the percentage error. Only for practical. Theory, you go half of the smaller scale. Okay. For practical, another method I want you to adopt is the second one. This one. If repeated reading have been taken, then the uncertainty can be half of the range. Half of the range of the value. If you repeat it. As I told you, all raw data must be repeated. Okay. L do you repeat on top? So you repeat. Okay, let's say you repeat. Let's say L, for the case of L, you got how much? 15.1, 15.2, let's say. So average is 15.1, right? Okay. So the uncertainty, they say what? Half the range. How much is the range here? What is the range here? Range of your value, how much? 15.2, 15.1, range is 0.1, correct? 0.1. Your error is half of the range. Okay, that means your error here is how much? Half of this range. So it should be 0.1 divided by 2. That's your changes of value. Half of the range. Always works. You follow this method. Okay? For practical only. Okay. So let's see. Repeat. You got another one. Got 15.0 and 15.4. Quite big. So what is the change of L? Half of the range. Range is how much? 0.4. So divide by 2. 0.2 is half of the range is your uncertainty. That quantity. That's next method. So percentage error, please follow the second one. Always works. But one student got very accurate 15.1, 15.1 and repeat. Range is 0. So uncertainty is 0, right? He did very good job. But Cambridge never accept that. Reason? Sometimes.
I could say if coincidentally he got the same.
Getting same is good, but you are. Yeah. So in a real exam, you repeat and you got the same value. What do you do? You purposely put makeup on. Have something. Let's say you measured 15.3. So 15.3, put it as the average. Then the other two maybe 15.1, 15.2, 15.4. So the average get 15.3. You make up and save time also. But when you do a real research, okay, don't do this. Real research, you just repeat as many, take the average. Okay. Okay. Okay, next. Correct calculation for C. C, you calculated correctly. C, they give a formula, right? What is the formula?
C equals
Square root L over A. Square root L over A. So L, how many significant figure? Maybe 3, let's say. A, let's say 2 significant figure. So C must go for the least one. 3, 2. So final answer is 2 significant figure. I don't know how many significant figure you got L and A. Go for the smallest for C. So C to the SF given by the candidate. So correct calculation, you get 1 mark. Easy to get this mark. Don't ever put a lot of significant figure. You don't know how to put how many significant. I say 3 SL. Correct justification for significant figure. Okay. C2 also something new. Justify why C you put that much of significant figure. So how do you blame? C is what? C is root of L over A. Root of L over A don't have root. Okay. Okay. So they ask, okay, when you put 2 significant figure, justify why you put C as 2 significant figure. So what you have to say? The significant of figure of C is depend to significant figure of what? In this case, significant figure of C is depend to significant figure of L and A. I get 1 mark. You must tell who determines the significant figure of C, the L and A. Then what do you say? Because L is 3 significant figure, I don't know, I just give example. A is 2 significant figure. Therefore, C go for the smallest significant figure, which is 2 as a best answer. Okay.
If I go for the 3 as a instead of the 2, how do I justify it?
When it comes to justification, 3 SF also accepted. But if I were you, if I see they ask to justify, I go up, I follow the rule. two, then I write 2 significant. Question 2, they always ask for justification for the significant.
But if my L I put 15 cm, then I convert it to mm, become 150 mm, then it becomes 3 cm.
15 cm, 15 is 2 SF. You write meter is 0.150. You change to millimeter, 15 cm, so 150. Still 2 SF. The 0 is a joker. You can consider it as significant figure. You don't consider also can. Like, so it still can consider as 2 SF. Okay, so that's something new, significant figure of candidate, and you must, correct justification. SFC linked to significant of D and L or D and L, diameter. Sorry, area is depend to diameter, right? Not A. A is the calculated value, right? How do you get the A? What is the raw data? Your diameter. The significance of C is depend to the D and L, not A and L. D and L, diameter and L. Okay. Okay, so raw values for time t nearest to 0.1 seconds. Time taken is 0.1 second or better, 0.1 or 0.01 acceptable. Okay. And the time with unit, the range is your period you get from 0.5 to 2.0 seconds. The period. The period, do you repeat 5 or 6 times? I don't think so. You're going to oscillate many times. If you can go, how many times you can win? He went that day. 5 times? No. Oh, so not even one. Then you just put the period. If you best bet is what? A number of oscillations. Let's say 5 oscillations. Best is 20 oscillations. Minimum they allow is 10, not less than 10. In this case, they never put repetition. You must repeat it until 10 times because they know it never oscillate. Just put period value. Okay. So real exam, if you can go at least 10 oscillations, take the time. Okay. Yeah. Because your stopwatch can be 0.01 also. Yeah, accepted. 0.01 or 0.1. Okay. Okay, next. Okay, second value of D and L is successfully repeated. Second value of T taken quality. D1 should be greater than D2. The second, first diameter is bigger than the second, of course. First one is thicker wire, right? So D1 should be greater than D2. Don't care what value you pull up, but D1 must be greater than D2, of course. And second T first greater than the first value of T. Thinner wire period is bigger than the thicker wire. Thicker wire period should be shorter. That makes sense. Lots of atoms, they turn it, let it go, they arrange back big force. Fast they can restore. Thicker wire. Okay, so these all are easy marks for the question 2. This is something new. Okay, this part. Okay, two values of k calculated correctly. Do they ask you to calculate k? So calculate the k. Okay, so you already calculated the k. You see, what relation you are proving here? C equals to root of L over A. Did they put proportional or equal? Then how do you find the k?
There's another formula for
Oh yeah, what is the formula?
T equals to T.
Okay. Okay, science. You are trying to find relation between T and C. Okay. This is the formula the scientist said given to you to prove only with two data. Okay, two data. So what we do, if T proportion, if this formula is correct, K must be constant. Have to be a constant. So what do you do? Find the two value for K for two sets of it. T over C, find the K. Then, of course, you get a different value because it's experiment. Okay, now they ask you to check whether it's valid or not valid. The relation, is it valid or not valid? So how do you need to know? You find the percentage difference between the K. K1 minus K2 over K1 times 100%. This is the formula you must use. On the top, they give an empty slot, right? Empty space. For you to do this calculation. Find the percentage difference of your constant. Okay. First K, you got 2. Second K, you got 2.2. Find the percentage difference of the K. So, K1 minus K2. Okay, the differences. So K1 minus K2 is a modulus law, kind of like modulus. Modulus means make it always positive. You can go K1 minus K2 or K2 minus K1. It's fine. Big minus small. So once you got 2, another one you got 2.2. The changes in K. K1 minus K2 how much? 2.2 minus 2. How much you get? 0.2 on top. Divide by at the bottom K1 or K2. Accepted. One of the value. Okay. Then times 100% and see the percentage. If the percentage less than or equal to 20%, then we say it valid. More than 20%, we say it not valid. Okay, the cutting point they given is 20%. Okay. So we say the relation is okay lah. So valid looks like correlate. Okay, valid. Okay. When you go to PhD, I think F equals to ME, that formula. They also do this to find a constant, and they check the differences in the constant. If it's very, very small, I think Newton, I think maybe 1%, I don't know. Very small, then that equation is not considered as valid. Okay. For A levels, cutting point is 20%. Okay. Last time they used 10%, now they use 20%. I think you go for 20%. Less than 20% you say valid, more than 20% not valid. Actually, they are not checking, second experiment, they are not checking the quality, no. They're checking the how you put the reasoning. That's what they are testing. Okay. Okay, so until here, you should be able to get most of the marks. The problem is the last part. This is 8 marks, a lot. First question 20 marks, you must strike most of the mark. First question is must score at least 18. Second question out of 20, couldn't lose mark because of the last part. Last part is creativity. What are the 4 problems you faced? Out of 8 marks, 2 marks, always standard answer. You always can use that. What is the 2 standard? The standard answer, the first one. The reading not enough to draw a conclusion. 2 data cannot conclude their relation. 2 data is very limited. Okay. So that's the limitation. The improvement, what do you do? Take more reading, plot graph. And evaluate the relationship from the graph. Take more readings and plot graph and evaluate from the graph. That is always standard answer. Every paper doing experiment, second question, always two data, so you can tell this. Okay. This one do not credit. That one, although they wrote no marks. Wrong. So in your mind, you only have 6 marks to score. 2 is already there. Write this always. Another 6 marks must be something. What you must tell, what problem you face, how to overcome. How to overcome means you can introduce a new instrument, new technique, or new technique how to measure. For example, like diameter, sometimes they give a ruler. So you see, ruler is not suitable to measure the diameter of the wire. So improvement, use a vernier caliper. The technique, instrument you can introduce. Okay, there is 1 year. 2 things must be done at the same time. Need to drop at the same time. Need to view at the bottom when it touches the ground. What is the time taken? So difficult because the object reach the ground fast. Okay. So the student, what is the limitation? Is it difficult to do 2 things at the same time? Limitation, improvement, FN system allowed. That makes sense, right? FN system, logical, so give more. Okay. So kind of like that, logical improvement. Okay, see here, this experiment, the first B is difficult to judge the beginning and the end of the cycle. Yes, that's one big problem. You don't know where it starts and where it stops. That's nothing is written there. So how do you solve it? Have a marker or sticker. Yeah. So that must be in your mind when you do the experiment. Difficult to judge the beginning and the end. Draw a line, mark on the mass. As a reference point. Where it starts, where it ends. Okay, next, wire not straight. Wire not straight? Wire not straight or got kinked? Kinked means the cross-sectional area is not uniform. Some part got thinner. Then turning wrong. So kinked method straightening the wire use a larger mass. Larger mass can straighten the wire. Difficult to measure the L with reason. Difficult to measure the L because the ruler is not perfectly vertical. Okay. So measure by using a set square. Or make sure the ruler is perfectly vertical by using a set square to measure the L. So difficult to measure the L. The meter rule awkward to position parallax error. Yeah, parallax error is another problem. Marking L before putting detailed method using set square or ruler. I think the second method is good. A string with detail, use tape measure. Use the tape to measure. Yeah. So ruler with the set square is allowed. Set square alone is not allowed. Okay. Maybe the set square not enough to reach the spring. Right? Ruler with the set square. Okay. Then yeah, this one wire slips. Better method to gripping wire. Wire slips. Oh, from the clip. 2 wooden blocks. Wrap wire around the clamp, use 2 wooden blocks instead clip. Yes. Maybe the clip is not that strong. When you turn it, I think it slips. The wire slips. The better use a wooden block and you clamp it more tight. You can use more. Mesh swings as well to rotate on the rod. Better method to attach a clip to the rod. Sample glue to the rod. Mesh swings as well as rotates. It rotates, but it swings too. And it swings too. So what is it? Better method of attaching the clip. Glue it. Glue it. How glue it can solve the problem?
What is that?
They said we want it to rotate, but he said it's rotate at the same time it's oscillate. Rotating and oscillating.
But isn't that like supposed to do that?
Because they want you to oscillate, they want it to rotate only.
But isn't it wheel is not an oscillation?
That's what they said. It's happening. Better method of attaching, how glue can solve the movement problem. Understand? Yeah, vertical. Okay, let me think about this part. Short, thicker wire has to few cycles dampens quickly. Video timer replay frame by frame. Yeah. The time is too short. Use a video, just a timer. Okay, record it. Hey, class, this is the first experience for you. This is how your exam question going to be. So the next lesson, next practical, all going to be like this. Prepare for your second question. Okay. Limitation improvement. We will go about it. We come to next experiment. Okay. So I stop here. You can get this from the website. I post it into the text. Okay, these marks. Okay. Yeah.
Instead of using an assistant, can I just use the slow motion, like the camera?
We give few options. Yeah. Camera one of them. Down there. Okay. Okay. So this part you need your creativity now. Creativity. Think how do you can be improving.
So like for the person, I think it's just really lie because we need to get the reasonable answer.
Yeah.
You can actually check if you like small line.
Not for the second question. First question is.
Like for example, if we do that, we did it like an observer look at all
Nobody can do it.
just
From far away.
not like actually.
You can do whatever you like. You can do whatever you like. But yeah. If you do wrongly, they won't. They just observe. They won't. Maybe it's like a present for you. Happy birthday. Happy birthday.